What's going on, guys? Welcome to Amigoscode. In this course, I'm super excited because you guys have been requesting it for some time now, and here it is. So in this course, I'm going to teach you everything you need to know about Spring Data JPA. We're going to start off by understanding what exactly is Spring Data JPA. Then we're going to connect to a database. So we're going to have a database where we can test our changes. And more importantly, how does the mapping from Java classes to your tables in your database does work. You will also learn about the Hibernate entity lifecycle, which is really important for you to master Spring Data JPA. You also learn about queries, paging, and sorting. And the bulk really, it's when it comes to relationships. So one-to-one, one-to-many, many-to-many, and more importantly, understanding all of the annotations associated with these relationships. You will also learn about transactions and a lot more. So this course is what you've been asking for. I've put a lot of time and effort on this course. I hope you enjoy, and you can access the full course on my website, and I'm really looking forward to it. Without further ado, let's kick off this tutorial. Spring Data JPA is an amazing framework that abstracts all of the complexity needed for you to interact with your databases. So if you're new to my channel, go ahead and subscribe, give me a thumbs up, and if you haven't joined the private Facebook group as well as Discord, go ahead and join. I'm waiting for you there. Now, Spring Data JPA is an abstraction on top of JPA and Hibernate. So JPA stands for Java Persistent API, and basically it's a specification for accessing, persisting, and managing data between Java objects. So right here you can see that we have Hibernate. So Hibernate is one implementation of this interface. There are other implementations, but Hibernate is the most popular one. And basically what Hibernate does in a nutshell, it takes any Java object right here, and then we have this abstraction called object relational mapping, which means that we can have a Java class, which we can then map to a database. So that Java class is represented as a table in our database, and then we can perform various CRUD operations, as you will see in this course. And in here, as I said, Spring Data JPA is an abstraction on top of JPA and Hibernate, which makes it super easy for us to work with applications that needs to access database. So it's all about the persistence layer, right? So Spring Data JPA reduces the boilerplate code that we have to write. It gives us lots of generated queries, as you'll see in this course, and we can access our databases without having to write any single line of SQL. And that is through repositories, which you will see in a second. So it's really nice. And where Spring Data JPA shines really is when you are working with Spring Boot applications. So it makes the integration between Spring Boot applications and JPA in a much nice way without you having to configure a lot of things. So this is Spring Data JPA in a nutshell. Without further ado, let's kick off this course. For this course, I'm going to be using IntelliJ as the IDE of choice. And specifically, I'm going to be using the IntelliJ Ultimate Edition. So we have two versions. We've got the Community and the Ultimate. Now, because we're going to be doing lots of database work in this course, the Ultimate Edition gives us the database functionality right within IntelliJ, which means that we can see the tables, we can see the indexes, we can perform queries, and it's super, super nice, as you will see throughout this course. And one thing with the Ultimate Edition is that it's not free, but there is a 30-day trial which you can use. So I would definitely recommend you to use the Ultimate Edition if you can, given that there is a 30-day trial. However, if you cannot use the Ultimate Edition for any reason, go ahead and use the Community Edition, which is absolutely free, but it doesn't give us the database GUI client. So this is one disadvantage. And as you'll see throughout this course, I'm going to be performing queries, joins, creating tables, all of that good stuff. And you'll see how amazing this IDE is. So go ahead and download IntelliJ. And if you want to learn more about IntelliJ, I've got a full course just on IntelliJ, explaining how to use all the keyboard shortcuts, navigation, and all of that good stuff. So if you want to download IntelliJ, the best way for you to download it is through this application called Toolbox in here. So search on Google Toolbox, and then you can download all of the IDEs that JetBrains has to provide. For this course, I've prepared this GitHub repository where you will have access to all of examples that you will code throughout this course. So in here, you can see that I've got this awesome image, the course description, and then check out branches. So for each section in here, we have branches. So you can see that we have section 1, 2, 3. So at the end of each section, I have committed the code so that if you are stuck, you can refer to the source code. But if you have any questions, go ahead and engage on the private Facebook group as well as Discord. So in here, the main branch is the starting point. So this is where we're going to begin our journey learning Spring Data JPA. So let's go ahead together and click on code, and in here, let's grab this link. So from SSH, Command C, and then inside of IntelliJ in here, so this is the main page, I'm going to say get from VCS, and then I'm going to paste that and then clone. Just give it a second. It's actually resolving all the dependencies, and that's done. Now open up the project tab in here, and you can see in here we have the folder structure. So the folder structure is really simple. So inside of source, we have the main, and then Java, and then application. So this is a bare bones Spring Boot application. And inside of resources, we have application.properties, which I will explain in a second. And inside of pom.xml, this is the Maven configuration. So you can see some metadata. In here, I'm using Java 15. So if you are using Java 11, for example, you can change this to Java 11. And also, you can see that we have a couple of dependencies in here. But the one that we really are interested are these two: Spring Boot Starter Data JPA and this one here. So org.postgresql. So this allows us to connect to a Postgres database. This is pretty much the folder structure. So as you can see, it's really straightforward. Next, let's go ahead and get the application up and running. And for that, we need to understand the application.properties. In order for us to start the application, let's go ahead and open up the application.properties. And in here, I already have this configured for you, so you don't have to waste time creating all of this. But let's go ahead and understand exactly what all of this means. So here, this is the connection URL for our database, username and password. Because it's local development, we don't have to specify these specifically on a Mac. But if you're on Windows and if your database has a username and password, put those in here and you are good to go. Then in here we have Spring JPA configuration specific. So The first one is Hibernate DDL Auto, and this configuration here simply means that create the schema and before the application shuts down, drop everything. So the reason why we have this configured like this is because we're going to test various different things with Spring Data JPA. But I'm going to cover this property more in detail later down in this course. Then we want to see the SQL statements that Hibernate will generate. Here we are specifying the dialect PostgreSQL. And then we also want the SQL to be formatted. And this is pretty much the configuration that we need for this course. Now in here, you see that we have Amigoscode. So this is the database name. So in here, if I press Command and then L, and then do a \L, you can see that I do have this database called Amigoscode. Now you can pretty much connect to any database that you have in here, or if you want a brand new database, all you have to do is say create database and then the database name. Let's say hello, for example. There we go. And now you have the hello database inside of this server, \L. And you can see that hello is here. And in here, now you would change this to hello. Right? But for me, it's Amigoscode because by default, Postgres app creates a database with the associated user. So in my case, Amigoscode, for you, it will be your username. So once you have the database configured, go ahead and press play. There we go. You can see that it is starting and there we go. So it started correctly, no errors, everything is up and running fine. If I stop this, and if you don't see this play button, let me close the application.properties. In here, inside of application.java, so this class, you should see this play button, or you can just right click in here and then say run application. And there you have it. So we have now successfully cloned and started the application. And from this point onwards, we are good to go to learn Spring Data JPA. One thing that I want to show you here is, remember I said that we have all of the branches. So if I click on this button here, so we can see the branches and you can see all of the remote branches. So section 1, section 2, section 3. So at any point, if you want to check out any specific branch, you can do it. So let me actually show you. So here, let's say that I want to check out this branch. So check out branch 5, or actually section 5. And you can see that immediately we have a bunch of new code. So it's just resolving dependencies. There we go. And now if I start the application, so this time it might take a while and you should see a bunch of logging. And there we go. So you can see that's some SQL and there you have it. So also in here is if I press Q in here and then connect to Amigoscode. So Amigoscode and then do a \DT. You can see that we have these three relations. And for this course, I'm not going to use the terminal because I don't want to be switching windows back and forth. So everything that I'm going to show you is through here. So in here, we have this database tab in here, and here we can configure the database, and I'm going to show you in a second. But from here, we can actually see everything inside of our database. So there you have it. Now, let me actually stop the application and then let me switch to main. So main is the starting point. And there we go. Right, so we have the database up and running. Now inside of IntelliJ, let's connect to our database. So here I'm going to click on this database tab and new data source, and in here choose PostgreSQL. So for example, if you want to experiment this course with MySQL, for example, you can definitely do it, but I wouldn't do it until we complete the course, because I want you to get things working nicely. And by the end of this course, you will know everything you need to know about Spring Data JPA, allowing you to connect to other databases without any issues. So here, let's first choose PostgreSQL. And then in here, I'm just going to leave this as default. So the name, and you can change it if you want. Then the host is localhost. The port 5432. So that's the default. If you have changed it, then you need to change it here as well. But for me, it's the default. Then authentication, user and password. So because we are doing local development on a Mac using Postgres app, we don't have to specify these. And if you're on Windows, as I said before, you might have to enter the user and password that you have specified when you configured your server. Then the database in here, so instead of Postgres, choose the one that you have created. So in my case, this will be Amigos and then code. And I'm going to test the connection. And you can see that it did work. Now, if you see a pop-up that says you need to download the driver, go ahead and do so that you can connect to the database. Now I'm going to apply and OK. And you can see right away in here, we have databases 1. We've got the roles in here, table spaces. If I click on database, this is Amigoscode. We have one public schema, which is currently empty. And in here, so what I want to show you is, so if I collapse this, you saw that we have this console, and this is where we can perform select statements. So what I want to do first is I'm going to switch branches quickly, because I want you to see that, for example, if I switch to section 6, so in here we learn about various different things, including one-to-many, many-to-many, one-to-one relationships. So section 6 checked out, and I'm going to run the application. And by the way, you don't have to do this. I just want to show you that from here we will get the tables, and then we can perform some queries. So there we go. So you can see that the application started, no issues. If I collapse this, and now if I refresh, you can see that now we have 5 tables and 4 sequences. So here you can see that we have book, course, enrollment, student, and student ID. And basically all of this here represents this ERD diagram, which you will learn throughout this course, and how to build all of this. So now if I go back, and inside of this console here, we can have select statements. So here I can say select, and then star from, and then student, and we can join. Let's say we want to join to card, and we can also join to books like that. And if I run this, you can see that in here we have the output, and there you have it. So this is why I want to use the Ultimate Edition, because everything is integrated and I don't have to switch screens, which makes things much easier for you. So if you don't see this console, what you can do is create a new console. So here, right click, new, and then query console. And then you can perform queries, you can say selects, so on and so forth. And the cool thing here is we get auto completion, and it makes writing SQL much easier than using the terminal. If you want to learn about data grip, which this is actually part of data grip. So data grip is this awesome IDE in here, which I have installed. So this one here. So if you want to learn about data grip, go ahead and check my free course on data grip where I teach all of this. Basically, this is a subsection of data grip embedded into IntelliJ Ultimate. This is all for this video. Let me actually stop the application. And again, let me switch branches. So make sure that you are in main from now on. Let me check out, and there we go. And then application.java should be empty, as well as no extra classes inside of the main package. This is all for now. Catch me on the next one. Let's begin by taking one table, and then we're going to build the Java class and then construct a table in our database. So right here, you see that I do have this entity and it's named student, and it has few properties: ID, first name, last name, email, and age. And in here, email should be unique. And also you can see that the ID is the primary key, so PK. And I also have the data type for them. So here, big serial, not null, meaning that the value must be present, so it cannot be empty. And the same for first name, text not null, last name the same, email the same. And then for age, the data type is an integer. So what we're going to do then is take this. So this is our ERD diagram. And again, we're going to start with student and then move to the bigger picture. But for now, let's start small. So we're going to take student and then build the Java class. Now, in this class right here, we have to define a few things. One, we have to tell Spring Data JPA that this class student will be a table in our database. And I'm going to show you this in a second. And then we also need to specify the entity. So these two are annotations that you will see in a second. And then as with any Java class, we need properties. So the properties will be the exact same ones that we have in our ERD diagram, but we will use some annotations that will tell that these properties are inside of our table. So once we have everything configured, then we should see in our database the corresponding table. Right, now let's go ahead and open up IntelliJ. And what we're going to do here is the following. So in here, let's go ahead and create a new class inside of com.example.demo. So here, create a new class, and the class name will be student. And right here, I'm going to say don't ask again and then cancel. And now this is a class that will represent our entity in our database. So here, let's go ahead and define the properties that we need. So first, I'm going to define the ID, so private, and then I'm going to say long, and this is the type of the ID, right? So here, let's say ID. And then we also need to specify the first name, so private, and this will be a string, first name, private, string, last name, and we need email. And finally, we need the actual age, so private, and then this will be integer, and this will be age, just like that. And that with semicolon. Now let's go ahead and add the getters and setters. So here I'm going to press Control and then enter. And here I'm going to say getter and setter. So select all of that and then OK. And finally, or actually not finally. So first let's have the to and then string, and select all of those as well, and make sure you use the plus. So you have actually different implementations, but let's just use the one that IntelliJ gives us by default. Okay. And right here, what we are missing now is the actual constructor. So let's go ahead and add the constructor. There we go. So I've just pressed Control Enter and then select all of those. Okay. And there you have it. So let me put this on a new line, just like that. So right now, this is our student. We've taken this entity from our diagram and we've built a Java class. So right now, we're not using Spring Data JPA. So far we have just a class with some properties. And you can see all of these properties, so 5 properties right here, they correspond to our design right here. Next, let's go ahead and tell Spring Data JPA that we want this class that we've just created. We want it to be a table, and also we want these attributes to be a column in our table. To map this class to a table, we need to use this annotation called @ and then entity. So the package that this should come from is javax.persistence. So you can see that we also have org.hibernate.annotations, and we should avoid everything from Hibernate and use everything from javax.persistence, because if you want to change, for example, from Hibernate to a different provider, nothing will break. So here, choose the first one. And now in here, we need to basically, we can just remove this for now. And let me actually show you what this means. So right here, you also see that we have this symbol, which is really nice. But now, so if I show the diagram, in here, we've said that we have an entity. So this student.java is an entity. And then this is now mapped to a table in our database. We also have this other annotation called table, and I'm going to show you in a second. So here, let's go ahead and just run the application and see what happens. And this gives us an error. Now, if I scroll up, you can see that the error says no identifier specified for this entity. So when you work with databases, it's good practice to have identifiers, i.e. primary keys. And in this case right here, so our ID is our primary key. So here, what we need to do is tell that this ID right here is a primary key. Now, the way that we do it is by saying @ and not # @ and then ID. So again, have a look. You've got 2 annotations. So always make sure you choose the one from javax.persistence. So there you have it. And you can see that we have these special symbols right here, but let's go ahead and try and run the application again. And there you have it. So check this out. So if I show you in the logs, so you can see that the application started, and then right here, because we've enabled logging, so right here, so if I open up application.properties, remember, show SQL, you can see that we have this section right here where it says Hibernate, and then this is the query that it was executed against our database. So create table, student, and then ID, age, first name, last name, primary key as we specified. So which means that if I open up my database in here, and I think I need to refresh this. There we go. And you can see that I do have student right here. So this is so nice. So we haven't done much and we already have this class mapped to our database as a table. So obviously we have to do a little bit more work to configure, but this is the bare minimum that you need in order to map a class to a table in your database. So if I also show you through the terminal, so right here, so if I do a \d, you can see that we have now the student table, \d, and then t, and then student. Or actually, this should be \d student. And you can see that we have the exact same thing, right? So ID, age, and we also see that we have an index right here, right? So index student primary key, and it's B3. So we have more work to do right here. So remember, we have some constraints. So we said that this should be text, not null. And then this is a big serial, which is backed by a sequence. So we also have to change this, but you can see that this is the bare minimum that you need in order to map a Java class to a table in your database. And one last thing that I want to mention to you is when you have your entities, it's always good practice to add a name. So in here, in my entity, I'm going to say name. And then here, this will be student. So this will be, so basically the default is the actual class name, so student, but it's good practice to be explicit about the name right here. And I'm going to show you exactly later on where to use this name right here. But for now, if you don't specify, the default will be the same as the class name, but it's best practice to have full control and specify the name yourself, because sometimes you might have a really long class and then the entity name might be different. So let's say that this is like student ABC, for example, but you want to call it just student, right? You can do it. And then in here, later on, you'll see where we're going to use this and it will make fully sense. But for now, let's just keep it like this. Now that we have this class mapped into this database, let's go ahead and take care of these properties and configure it exactly the way we want. So for the ID, what we want is a big serial, and the big serial data type is backed by a sequence. So let's go ahead and configure a sequence with our specified ID. So right here, let's go ahead and say that we want @ and then sequence generator. And in here, this will take a couple of things. So we have to specify the name. So let's go ahead and say name equals to, and then student, and then sequence. We also have to specify the sequence name. So comma. And let me duplicate this because this will be the same. So sequence and the name, oops, not emojis, just like that. We can specify the catalog, the schema, and the initial value as well. But here, what I want to specify is the allocation size. So allocation size, and this will be 1. So this is how much will the sequence increase from. We want to go from 1, 2, 3, 4, 5. And you can see that the default one, so if I press Command P, the default initial value is 1. So we are good there. So now that we have the sequence generator, we need to say that this is @ and then the value. So the generated value for this will be, so again, within parentheses. So I'm going to say that the strategy will be a sequence. So right here, generation type and then sequence. And here, let me add the static import just like that. And then here, we need to specify the actual sequence name that we specified. So Command P, you can see that we have the generator there, and the generator is the one that we've just defined above. So this one right here. There we go. And we are good to go. Now, if I restart the app, there we go. So you can see that we have create sequence, student, start at 1, or actually start 1, and then increment 1. So this is this value right here. So increment 1 is the allocation size, and then start at 1 is the default right here. So now if I open up, so in here, I'm going to open up the terminal, and I'm going to say / and then D. There we go. And you can see that we have the student sequence right here, right? So this is the name that we've specified in here. So let me collapse this, and let's see if we can see the sequence from here. So here, if I refresh, yes, there we go. So you can see the sequence is right here as well. So there you have it. Now our ID is backed by a sequence, which is the same as the big serial data type. Next, let me go ahead and teach you about the @column annotation. Now let's go ahead and learn about the @column annotation. So right here, if I open up the database, you can see that, let's have a look at something here. So if I collapse this, so in here, we have the ID right here, which is this ID. We have age right here, which is this one. And then we have last name. So this one is important. So last name, you can see last name right here. And instead of being last name, camel case, it's now with underscore. So there are times where we want to have full control of the name as well. And it's good practice to specify the name that we want for our columns. So here, what we need to do is as simple as, let's go ahead and add a @column for every single property that we have. So here, @ and then column. And in here, we can specify a couple of things. So for DID, what we want is to say, this will be name. So let's just say on a new line, we want name equals to, and then this will be ID. And we also want this to be updatable to false. Basically, we don't want no one to update this column. And you can see that we can specify some other attributes, and you'll see this in a second. So now let's move on to first name. So I'm going to say @ and then column. And here, this will be name equals to, and then first, and then underscore name. So if you want to change this for a different name, you could absolutely do it, but this is what I want. And also right here, you see that we said that name is text, not null. So here, the way that we do this is as follows. So to say that a column must not be null, because right now it can be null. So we say this. So if I press Command P, you can see that we have nullable, and the default is true. So I'm going to say nullable and then false. And also I want the column definition to be, and then text, because right now it's varchar 255 and I want to be text. And that's it, to be honest. So let's take this and then paste it here, because this will be the same, but this will be last and then name, just like that. Add a space, and this should also have a space there. And yeah, just like that. And let's do the same for email. So I've just pasted that. So email, and right here, nullable. And then the email, this will also be text. But what I want for this email is to be unique right here. So unique and true, right? So right here, you can see that we have a unique constraint on the email. So that's for email, and then age. So right here, for age, all we have to do is say column. And then here, I'm going to say name equals to, and then age. That's really it, what I want for the columns. And there you have it. So now if I run this, and also you can see like we have these quickly red lines, and I want to show you exactly what this is in a second. But if we run this, so this is not stopping us from compiling. And there we go. So you can see that we have a couple of things, but now have a look. So have a look. So in here, we have alter table and then add constraint. And this is the constraint name right here. So if I expand database, and let me collapse this for now, and then refresh in here, you can see that now things have changed and we have a couple more things. So ID, age, so nothing changed there. Email is text, first name, last name. And then we have a couple of constraints right here. So the unique constraint for the email and also the index for email right here. So you can see we have an index as well as this constraint. And the name is kind of ugly, and I'm going to show you exactly how to fix this in a second. But for now, there you have it. We have now fully adhere to our ERD design right here. And actually, I think we forgot to add a not null on age. So in here, so let's go and add the right here, comma, and then nullable equals to false. And there you have it. So next, let me go ahead and show you how to fix these red squiggly lines right here. Right, the reason why I see these red lines right here is because I'm using the Ultimate Edition, and this gives us, extra features. So what we need to do is actually, if I put my cursor there, so right here, it says that cannot resolve age, assign a data source, and let's select the Amigoscode local host. Okay. And you can see that the red lines disappeared. So basically, this now gives me the flexibility of, so right here on the left hand side, if I click on persistence, you can see that I do have access to a couple of things here. So we have student, and you can go through the columns right here, but we also have the abstract persistable, and then auditable. So this is JPA specific, which you don't have to worry about for now. So there you have it. And also one thing that I've noticed is that in here, if I scroll up, I still have this red line, and this is IntelliJ telling me that I need to create a no R constructor. So let's go ahead and do that. And there we go. And now all of the errors went away. So next, what I want to show you is go to database. So right here, you can see that we have this unique constraint right here. So this name right here, it's like really ugly, like UK and then whatever. And basically we want to have full control of this name right here. So let's go ahead and learn how to tackle that next. All right, so to change this unique constraint name right here is as follows. So right here, let's go ahead and use the at and then table. So the same way that you saw, we have at column, at entity, we also have at table, because right here, the name of the table is the same as the class, but lowercase. So what we're going to do is we're going to take full control of that. So we're going to say that this name will be student, but also in this table right here, we want to specify some constraints. So here, if I press Command P, you can see that we have unique constraints. So let's go ahead and say unique constraints. And right here, this takes an array. So I'm going to add curly brackets, and then inside, I'm going to say add, and then unique constraint. And then we need to specify name. So here, I'm going to say name equals to, and we also need column names. So let me just put this full screen so you see exactly. So here, the column names, we can also pass an array of columns, but I just want the email. So this will be just email. And then here, this is where we specify the nice name. So here I'm going to say student, and then email, and then underscore, and then unique. Just like that. I know the name is a bit long, but it's way better than having that random name. So now what I'm going to do is actually run this because I want to show you something. So there we go. And right here, I can see that the constraint name right here hasn't changed. Still is UK and then this random number, right? So what's happening is that, let me actually show you. So in here, so if I refresh, you can see that still with the exact same name. Oops. So let me actually collapse this again. I'll actually expand this and you can see the random name. So the reason why that's happening is because we have defined the uniqueness in here. So in this at column, so if I search for, so here Command P, there's no way for us to override the unique column constraint. So what I'm going to do is remove this unique from here. And now if I restart the application, and in fact, this should go and then run. There we go. Now check this out. Alter table, student add constraint, student email unique, and then the unique constraint. So here, if I refresh this now, you can see that the name is now correct. And this is exactly what we want. So there you have it. So we actually managed to pretty much do everything from this diagram. We've taken this entity, we built a class that represents an entity, and the entity maps to this database that we have, and we actually took control of the columns by specifying the actual names that we want, the same with add table, and also the unique constraints, as well as the column constraints right here. So text not null, we've managed to do that. And we also managed to create a sequence for our primary key. And this is all for this section. In this section, let's go ahead and learn about repositories and how they help us to manipulate our entities in our databases. So right here, you saw that we've taken this ERD diagram. So student, we built a Java class, and then we mapped the Java class to a table in this database. So currently, that is all that we have. Now we need a way to be able to perform some CRUD operations. So create, read, update, delete, and possibly have custom queries that we can perform against our database. So with Spring Data JPA, we have this concept of repository, and the repository is simply a data access layer. And the goal is to abstract everything which reduces the amount of boilerplate code required to implement data access layers. So in here, you can see that what we're going to do is have this student repository, and this repository will be our data access layer. And this means that now we can add new students, we can delete students, we can search students, we can modify students, so on and so forth. Now, when we work with repositories, we need to extend the following. So we have a couple of interfaces that we can extend from. So we have the JPA repository, and this includes some JPA methods, as well as the CRUD operations. But more importantly, it includes flush and batch functionality, which you'll see in a second. So JPA repository extends paging and sorting repository. And this repository is mainly when you want to perform some pagination and sorting. And this repository extends CRUD repository. So this repository gives us some CRUD methods, and you'll see this in a second. So basically, this repository, so our repository, must extend one of the three. So JPA repository, paging, or CRUD repository. So let's go ahead and look at these interfaces. So I'm going to open up IntelliJ, and right here, I'm going to search for CRUD and then repository. And let me collapse this. And you can see that this repository gives us these methods. So save, save all, find by ID, exist by ID, find all, count, find all by ID, delete, delete all, and basically, you know, the basic of CRUD operations. So let's have a look at the JPA repository. So JPA and then repository. So there we go. So this one, as I said, extends paging and sorting. So right here, so JPA extends paging and sorting, and you can see right here. So you can see that we have find all, basically almost the same methods that we had with CRUD repository. So save and flush, which I'm going to talk to you about later. And basically that's it, right? And let's have a look at the paging and sorting repository. So this gives us the ability to pretty much just find by sorting and also by paging. So this is very important when you want to perform pagination. So, and also you can see that this extends CRUD repository, as I said in here, right? So extends CRUD repository. Now, what is really important is that you can see we have this T and then ID, the same here. So these diamonds, so this is generics. So the same in here and in here. And if I go back to JPA repository, you can see that we have the same. So this is working with generics, and the same with CRUD repository. So generics right here. So if you want to learn more about generics, go ahead and check my course on generics, where I explain everything you need to know about generics so that you understand what is happening. But in a nutshell, what this allows us to do is to pass any entity that we have and its data type for the identifier, so the primary key, and then we can use it to perform all of these operations. So save, save all, find, find all, so on and so forth. Now that you have an understanding of how this works, next let's go ahead and create our student repository and save some students to our database. Right, within IntelliJ, let me go ahead and open up the project tab. And what we're going to do here is create a repository for our student entity. So here, what we're going to do is create a new class. And this has to be an interface. And go ahead and type student and then repository. And there we go. So now we have this interface right here. And now we have this interface right here. So currently it's not doing anything because we haven't extended the repositories that we can choose from. So in here, either one of these two, or actually these three, right? So here, let's go ahead now and say, so if I put this full screen, let's say extends and then JPA, so JPA repository. And this comes from org spring framework.data.jpa repository, and this is the interface. So now what we need to do is actually, so in here, if I select or actually navigate to this class, so command and then click on it, you can see that we need to pass the type that we want to work with, as well as the ID. So the type in here, so what we need to do is the following. So the type is student. So that's the student class that we have. And then the ID is long. Now, if I open up the student class, so student class right here. So in here, you can see that the ID is long. This is why I've said long in here, right? So remember, I said the entity as well as its identifier data type, which is long. And to be honest, this is everything that we have to do in order to extend a repository and be able to use it. So obviously within this repository here, we can have a couple more methods, which I will show you in a second. But for now, this is the bare minimum that we need in order to interact with our database. Now let's go ahead and open up application.java. And in here, let's go ahead and create a method, and we're going to say command line runner. And this is so that we can have some code running after the application startup. So here, what we're going to do is the following. We're going to inject the student and then repository, just like that. There we go. And now we have to return. So in here, and this receives some arguments, which we don't really care at this point, and then semicolon. And also annotate this with @ and then bean. And there we go. So now this means that if I say student dot and then, student repository dot, you can see that now we have all of these methods, right? So we have get one, delete, find all. That takes an example, and this is to do with some querying. Find by ID, flush, save all, and you can save as well here. You can save a student, so on, right? So let's go ahead and say save and then S, and in here we have to pass a student. So what we're going to do is say new and then student. And what we're going to do is take this student outside. So right here, let's call it Maria. And then end that with semicolon. Now for the constructor, we have to pass a few things. So we have no arg constructor, or we have the one where we pass the ID, first name, last name, so on and so forth. So what I want is inside of this student class, I'm going to remove the ID from the constructor because the ID is generated for us. Remember, it's backed by a sequence and we don't have to do anything there. So just like that, and remove ID from here. Now, if I go back, press Command P, you can see that we only have to pass first name, last name, email, and then age. So let's say Maria Jones, and the email is maria.jones@amigoscode.edu, just like that, for education. And then for age, let's say that she is 21. So in fact, let me put this on a new line, and there you have it. So make sure not to type the first name and then column and then Maria, so strings, because this is some help from IntelliJ. So don't type this, only type this string right here. And then what we do is we call the repository and then save right here. So now let's go ahead and start the application. And there we go. You can see that worked. But now check this out. So in the logs, we can see that Hibernate performed an insert into student, and then it passed the age, email, first name, last name, and the ID, right? Because the ID is managed by the sequence and we didn't specify, and then it passed the actual values in here. So this means that now if I check my database, and in here we can jump to query console, and already have one console open in here, and I can just collapse this. Now I can say select star from and then student, and if I run this, you can see that we have the output. And what I'm going to do here is I'm going to say that I want this to be transposed, and check this out. So now we have one record in our database, and this is really cool. So let me open up PSQL / and then X, and this is to get the expanded display on, and then select star from and then student, and the exact same result. So there we have it. So you can see how easy it was for us to be able to have a custom repository which serves as our data access layer, and then manipulate our entity in our database. So if I go back to application, so you can see that from now on, we can use any of the methods provided by this student repository to interact with our database. If you have any questions, go ahead and let me know. Otherwise, let's move on.